Welcome to the OHBM educational program session on how to write a re-executable publication. This session is brought to you by RePRNIM, the Center for Reproducible Neuroimaging Computation, in conjunction with a number of our colleagues and collaborative partners. All of the material that you'll see in today's session is the most up-to-date and available at the RePRNIM OHBM Education 2022 GitHub repo. The purpose of today's course is to, in the course of a half-a-day session, do a completely re-executable publication. We'll do this using publicly available data and a fixed computational environment where we'll be able to perform a volumetric analysis designed to replicate a prior finding from the published literature. We will do this in a way that can be re-executed and consequently extended by others and demonstrate the importance of re-executability in the context of supporting the generalizability of the neuroimaging literature. Beware that we cannot, in the course of this program, teach you everything you need to know about how to do this. We will give you some general introduction and important concepts, and we'll give you a recipe that you can follow that will accomplish this task in the course of our session. Instead of trying to teach you everything, which will take many days, and then you may or may not succeed at getting to a final result, we believe that if you can get through this complete process firsthand and see in person some of the benefits of the approach, you may become more motivated to devote the necessary and the necessary time that would need to be devoted to learning the complete details of what you've just accomplished. The agenda is presented here. This is my brief introduction to the course. You will then hear about what a ReproPub is and why you would want one. You'll hear an introduction to the biological question that we're trying to answer in this context. We will learn a little bit about containers as a processing procedure in general, and then specifically this container that we will be using in this course. You'll get a brief introduction to a tool called DataLad, and then we will spend a good bit of time doing the exercise that takes you from data to published result in the course of just a couple hours. Then, if everything goes according to plan, we'll be back to look at some meta-analysis of the analyses that each of you do across this class, and then we can pool all of our data together in a mega-analysis of these results. And then we'll have a recap and a summary at the end. RePRNIM likes to conceive of a study in a sort of a set of classical phases of a study. There's study design, data collection, image analysis, statistical inference, and publication. We also like to think about best practices that can be applied to each of these phases. These include planning, version control, annotation, use of standards, and archival. So by considering each of the phases of a study and best practices in each of these areas, we really have a whole matrix of things that the investigator can be considering in order of using the best practices and invoking their study in the most re-executable way possible. So for example, in data collection, make sure you plan the collection, make sure you use version control of your collection results, make sure you annotate your data collections, make sure you use standards along the way, and make sure you archive that information in a way that can be found by the future you or others who want to replicate that. And that applies to each of these different domains. And in this course, we will use a number of the tools that help fill in specific pieces of this matrix in the context of our particular problem that we'll try to solve. There's a number of tools that are very important to what you'll be doing today. That includes Git and GitHub for version control for documents, and the documents kind of broadly defined. It can be data documents, it can be software, it can be scripts and things like that. We'll use DataLad for version control of data. Data and data processing fall under that version control of DataLad. and we'll use Py90M for the handling of distributed and annotated data. All of this is encompassing various standards that are very important to the community, including BIDS, the Brain Imaging Data Structure, which is a standard for imaging and other data representations. We'll use NIDM, the neuroimaging data model, a standard for annotation for neuroimaging and the provenance thereof. And we'll use Docker and Singularity, standardized, containerized versions for running computational analysis in controlled environments. What happens here, of course, we're trying to do in a way that maps on to what you may do once you get back home. In each of these phases, we're simulating something here that we hope you can generalize. In study design, we have a pre-prepared hypothesis, data acquisition, analysis, and statistical plan that we'll provide. At home, well, you need to create that for yourself, but make sure you plan ahead and create a design for each of your studies. Here for data collection, we will use a subset of a publicly available data set that's already in the BIDS representation. At home, make sure you collect your data and put your data into the BIDS representation. That will map onto here. For image analysis, we're running a pre-prepared container for an FSL-based volumetric analysis. At home, make sure to consider the use of pre-built containers or containerize your own processing so that you can use a container technology and share your processing and script and environment more easily. For statistical inference, we'll be using a canned linear regression using Py90M at home. Make sure you design scripted statistical packages or notebooks that can be shared with the data and connected to the data that you analyze. And finally, for publication, we'll be publishing our text, our documents, our data, our results, our processing to using Data Lab to GitHub. At home, this is an opportunity to publish where possible in peer-reviewed or preprint statuses, the data, the processing scripts, the containers, the results, and the statistical scripts they're using. So all of these are publishing opportunities and opportunities to disseminate your work, get credit for your work, and get credit for reuse of your work by others. So without further ado, let's do it, and let's turn the floor over to our esteemed presenters.